I'm Matthew. I work at Yammer. I'm a web developer. I've been working in a lot of different areas of the web stack, I guess for kind of a long time. But my home has always been JavaScript. So it's really exciting to be able to finally actually be able to use real JavaScript on the server and do full stack development. We use a lot of JavaScript at Yammer in a number of different environments. Our desktop app is JavaScript. Of course, all the web browsers for our web client. We use JavaScript in an embedded server-side environment called the Ruby Racer, which embeds a V8 process in Ruby. And of course, we've got a fairly new node service that handles all of our file uploads. So I'm going to try to talk a little bit about that. It's a pretty short time, so I'm going to try to keep it very high level and just kind of power through it. So the first lesson, this is all stuff that I wish I had known sort of going into the process, sort of lessons learned. And the first sort of most important thing is organizing your code and thinking a little bit beforehand as you're building. And part of this is sort of the good problem that we have in JavaScript and even more specifically with Node, that it's really, really easy to build something that's immediately useful. It's very easy to stub out a prototype that does most of what you want. Almost kind of too easy, because as the specifications grow and change, people make what seem to be very small changes to the code, to the specification, what you're actually supposed to be doing, and it ends up having a big impact on the rest of the code base. So it rapidly can devolve into the old school sort of PHP hairball code, especially because of the asynchronous, the callbacks. Some of us who've been using JavaScript for a very, very long time on the front end are probably pretty comfortable, maybe a little too comfortable with the inside-out programming of using callbacks and events. But trying to keep things a little more clear becomes really, really important if you want to be able to modify your code and make bug fixes. The other small problem is how to manage third-party dependencies in your code base, where to put them, how to organize the code. Right, so with that said, the other fairly significant problem is dependencies. The Node ecosystem is still really, really new. So finding the appropriate library to use, making sure that it does all of what you want or most of what you want, and how to deal with that 20% that doesn't do, that isn't what you want, becomes a bit of a problem. So the service that we're running is something that I started building. It's based on some code that I started writing very, very early. And NPM was very, very much not there at the time. The way NPM works now is probably what we would have wanted. Installing the dependencies locally makes application deployment a lot easier. But at the time, using NPM really wasn't an option for us. It wasn't something we could explain to our ops people that we needed and ask them to use it. The third-party modules that we needed to use were also not quite there. And some of that is bugginess because they're very, very new. And some of that is because we're all very, very focused here, I think, as JavaScript people on getting our jobs done and building cool stuff. So everyone is building these modules with the intent of using it for whatever their specific purpose is. Adapting that to something more general purpose or to your needs becomes a little bit more difficult. So what we're doing right now, we just kind of sidestep the whole thing. We have slurped all of the dependencies into our code base. We're making the modifications in place, pushing patches back upstream. This is obviously not optimal. We don't like copy, paste, modify in our own code base, and so doing that with libraries is probably not the right decision either. That's something that we hope we can fix. And now that NPM installs the modules locally, it's a lot nicer story. Deployment becomes a lot easier. You're not relying on this global thing out in the language somewhere, the language library somewhere. Right, so this is probably so sorry if you're offended by strong language, but this is a really important lesson, and it applies not just operationally, deploying all of the things like this talk, water being spilled and things not working, just assuming that things are going to go wrong is in general a good idea, but it also applies more specifically to the asynchronous programming model, right? So you do a callback, the interpreter goes along on its happy way, and in theory, something as good is going to happen and you'll be back in the area of code that you care about. Sometimes things obviously go wrong, and figuring out how to handle this in this asynchronous process that's juggling all of these different requests at once can get kind of complicated and hairy. So this is a pretty common pattern, I think, on the UI side, and it seems to work pretty well on the server as well, where you assume error condition. You basically throw an error or call a function that is an error handler, wrap it in a set timeout that you will later on cancel if things turn out okay. So just assume it's going to be bad, and if it comes back and everything's fine, if your unit of work successfully completes, you cancel the error. That's a pretty common pattern on the UI side. That doesn't scale well when the app becomes more and more complicated, so we ended up with something like an in-flight registry where each step in the process is given an ID. We basically have a big object literal with named keys in it for all the various steps being processed by all the different, associated with all the different requests. A unit of work goes off, and a lot of times, of course, it's something related to I/O, it's something asynchronous with a callback. We make an entry with the, basically it's a timestamp saying when this should be done. And we have a process watcher that pokes through this list every couple of seconds to see basically what's overdue. And if something's overdue, then we perform whatever the default error handling condition is, error handling code is. So that in combination with the uncaught exception means your process generally stays up and running. It's really, really important to log all of the errors in detail so that you know exactly why these unexpected things are happening. But even when they're, with this approach, even if they're unexpected errors, the request or your control flow knows that this thing should be in flight and should be coming back at some point. And if something goes badly wrong, eventually your process, your in-flight watcher is going to notice and tell that request, ship some meaningful request back to the browser, telling what to do. So that leads right into the next bit, which is visibility into your app, because the code, what's that? Oh, okay, thanks. Because the code base is pretty complicated. Our Node app is doing a lot of different stuff at once. Streaming stuff to the file system, shipping stuff off to Amazon, thumbnailing, it's doing all of this stuff at once. So knowing when there's some sort of a problem, which piece of the process went wrong is really, really important. So measure everything and build it in from the very, very beginning. It's way easier to start with something small that has a bunch of metrics built into it than go in and retrofit your complicated code base with all the appropriate metrics. Measure everything, log the shit out of everything so that you know what's happening. And I'd also like to point out here, we're now using this metrics library, which is a Node.js port of Coda Hale's Scala metrics library that Mike Ibe here wrote. So definitely check that out, see what you think, give us patches, please. This is the last bit, and I would actually say that this might be the most important piece of all. And that's because Node is still very, very new, and so things still kind of go wrong a lot. And if you rope in your ops people from the very beginning and work with them, there's a lot more goodwill, and they're a lot more patient with your bleeding edge Node service. If you talk to them first and make sure that you're sort of being a good citizen. So at Yammer, we've got a bunch of other services written in Java and Scala. And knowing up front sort of what is expected of an HTTP service at Yammer, knowing the things that we should do, so the deployment story, restarts, metrics, reporting, all of these things, knowing what we should be doing is really, really important. So talking to these guys up front and knowing what's expected, knowing what would make their lives easier, means that there's a lot less bitterness and angst when your service wakes them up at 2 in the morning, right? They're the guys who have to deal with that. So Yes, I think that's it. I'm MDE on Twitter if you are interested in this JavaScript stuff that we're doing at Yammer. I can point you to the other devs at Yammer who are dealing with whatever different technologies. We also have a developer center that Michael Rogers has put together. He's been working for us for a couple of months and really kicking ass. We're really, really thrilled to have him. So check out the developer center. I guess that's really it unless there are questions. How big is our node deployment? Right now we have a very small cluster. It's 3 servers. I do not have statistics on the number of uploads processed per day or anything yet. We're measuring it, I just don't know what it is. That's an interesting question. The question was, how do we sell ops on deploying something so new? There are a couple of different good reasons to deploy this particular thing as a node service. Some of it was the dynamics of the different teams working on it. At the time, this was sort of under the umbrella of the platform team, which was very, very JavaScript heavy. I think the ops guys also recognize the value of Node, that it's an important thing in technology. So getting some operational expertise in that is, I think they understand that that's important. Also the fact that the particular thing that we were doing, which is streaming file uploads, Node is very, very well suited to performing that kind of work. And I think they also recognize the importance of Node in the JavaScript world, and so doing interesting things with JavaScript in real life and production is something that you should do if you're interested in plugging into the JS community. It is political, but it's also badass. So, Anything else? Okay, so he's asking about storing the data for the in-flight registry in something like CouchDB. That's not particularly useful for us because this is processing file uploads, and we're tracking basically pretty short ephemeral steps. So it's like how long this file should take to be shipped off to Amazon. And once that upload's done, it's done. So just keeping that in memory is a lot more efficient. What's that? It's not something that would be appropriate for what we're doing, but if it's something long-lived, yeah, that would seem reasonable. Or if you need to communicate between nodes in the server, server nodes in a cluster, that might be nice too. We're actually using Redis cluster to communicate between nodes in the server. So if you're interested more in exactly what we're doing, definitely talk to me because I think I'm about to get the cane here, right? So, thanks.